Hello everyone, we are going to start the Newlands Law of Octave. It is really a very important to cover the history part of the periodic classification of element. So we already understood that what Dobereiner did in his triad. Now Newland gone through all the research done by the Dobereiner and other scientists of that particular time, and he arranged all the known element in increasing order of their atomic masses. And at the time of Newland, when he arranged the element, about 56 elements were known at that time. Okay, how many? About 56 elements were known at that particular time when Newland arranged all the known element. Okay, so he arranged all the element in increasing order of their atomic masses. Okay, when in 1866. Okay, Newland was the English scientist, and he arranged all the known element of that particular time in increasing order of their atomic masses, and he found some periodicity there. So he arranged element like the lightest element first, then second having atomic mass more than the first, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, like this. So he started arranging all the known element in increasing order of their atomic masses. And he found something different, like the atomic mass of every eighth element was similar to that of first. Means the property of eighth element was similar to the first, then property of ninth element was similar to that of second. See, if we will discuss here, that one is the eighth element for the first, but ninth one is the eighth element for second. Is it or not? Likewise, 10th element was 8th number from the 10th, so they were having similar property. 11th element having similar property than the 4th, like this. So when he arranged element in increasing order of their atomic masses, he found that property of every 8th element repeated, oh, or the property of every 8th element was similar to that of first. Is it or not? Yeah. Do reply.
Yes.
Yeah. So first we will write the theoretical part, and then we will discuss again. Okay. So his arrangement was proceed up to the calcium. Then after calcium, other element was not obeyed the law given by the Newland. Okay. So first we have to write the theoretical part of the Mendeleev's, or not Mendeleev's, the Newland's law of octave. So first point, Newland arranged all the known elements in increasing order of their atomic masses. Their atomic masses. Okay, and he found that what he found, the property of, I'm just changing the ink for that, the property of, or the properties of every eighth element was similar to that of that of first. Okay, he found that the properties of every eighth element was similar to that of first. Now, next point. Then he compared, he means who? Newland. He compared his arrangement with the note of music. Okay, like in Indian music we have first like note, it is sa, then we have re, ga, ma, pa, dha, ni. Sa, re, ga, ma, pa, dha, ni. Then again repetition of the same like sa, re, ga, like this. Okay, so as you can see here, this is the first one. We have second, third, fourth, fifth, sixth, seventh, and it is the eighth one. Then ninth one, 10th one. Then we have more. It is 11th one. So you can see here the property of every eighth was similar to that of first. Okay, is it or not? So the property of every eighth element was similar to that of first. He found such repetition in the note of music also, and he compared his arrangement to the note of music. That's why he gave the name called Newlands octaves. Okay, these are called as octaves of music. Octaves of music. Okay, so I'm just writing in the part theoretical part. Wait a second, very important, just do concentrate. Newland compared his arrangement to or with the seven notes of Indian music.
Sir, it was not actually Indian, it was British.
Yeah, but we are just comparing in India. So yes, you can say the British also, like we have do, re, mi, fa, sol, la, ti. Okay, we can compare that also. Or not Indian, we can write music, seven notes of music only. Okay, but in India we have sa, re, ga, ma, pa, dha, ni. Okay, but in Western music we have do, re, mi, fa, sol, la, ti. Is it?
Yeah, ma'am. Oh, yes.
Okay, so we'll write music. Okay, so and he named his arrangement as Newlands octaves. Newlands octave. Okay, so this is the like law, or this is a theory given by the Newland. So I want everyone had to take a screenshot, then we are going to move further. Take a screenshot, everyone. Done? Okay.
Sir, it's saying it can't take screenshots due to security policy. I don't know what's happening.
Okay, so here we have the Newlands octaves. Okay, how he arranged element in increasing order of their atomic masses. So that time, like atomic masses were discovered. That's why scientists they try to arrange the element in increasing order of their atomic masses only. That particular time. Okay. Okay. So see here, as we can see, he like made some mistakes also. Okay, which kind of mistake? like he plays metal along with non-metals. Okay, this is again one of the drawback. So we'll discuss one by one. So I'm just writing the drawback. See, this is the arrangement of element by Newland octaves. Okay, now we will discuss the drawbacks of Newland octaves. Drawbacks of Newland octaves. Okay, so first drawback we are going to discuss here. See, he arranged element up to calcium only. Okay, rest element were not obeying the law of Newland octaves. Okay, so this is the first drawback. So he could arrange okay, he could arrange elements up to okay, up to 20 element. Okay, rest elements, okay, rest element were not obeying okay, the law given by Newland. Okay, okay, so this is the first drawback of Newland octaves. Now second, see here, as you can see, hydrogen, fluorine, chlorine and bromine are non-metals, and here cobalt and nickel are metalloid, no, metals. Is it? See, they are metals and they are non-metals. So he placed metals along with non-metal, and this is the not correct. Okay, that's why this became the second drawback of Newland octaves. So see, cobalt and nickel having different property than chlorine, fluorine, chlorine and bromine. Is it? But still he placed them together. Okay, so I'm writing here for, see, Newland sometime arrange in see, or instead of arrange we had to write place. Okay, Newland sometime placed different metals or different elements, okay, which not showing okay. So Newland sometime plays different element, okay, which are not showing similar properties, like this. Okay, so this became the second drawback for the Newland. So we have to write here example also. Example, he placed cobalt and nickel along with along with non-metals, okay, and both are having similar property, different property, but still he placed cobalt and nickel being metal along with non-metal. So this is the second drawback. Okay, keep replying. Everyone do reply.
Yes.
Okay, okay, Then third one. Okay, see, he arranged element in increasing order of their atomic masses. That means according to his law, carbon 12, carbon 13 and carbon 14, they are having different atomic mass. Is it that means they have to place at like different position? Is it or not?
Yes.
Okay, but these are nothing but the allotrope of carbon, so he didn't place them different in different boxes in his arrangement. Okay, here his law is denied here. Like the law says, when elements are arranged in increasing order of their atomic masses, then the property of every element was similar to that of first. Okay, but here if we can see here, according to his law, carbon 12, carbon 13 and carbon 14 must be get the different position in his arrangement. Okay, but he didn't did that. Okay, that's why this became the third drawback for Newland octaves. Okay, so he didn't explain about, okay, he didn't explain about what? Allotropism. Okay, so what are allotrope then? Not allotropes, autotropes. It, what I'm saying, it is isotopes beta. Allotropes are carbons having like diamond, graphite and buckminster. They are allotrope. These are isotopes. Okay, so he didn't explain about isotopes. So what are isotopes? Elements having same atomic number but different atomic masses. Okay, so I'm writing here what are isotopes? Elements which have same atomic number, but different atomic mass number. Different atomic mass number. Okay, everyone?
Okay.
Yeah. So this became the third drawback for Newland octaves. Okay. Next. Okay, fourth one. See, that particular time only 56 elements were known at the time of Newland. So there was no provision in order to arrange the new existing element in his arrangement of element. Is it or not? Like after the Newland, noble gases were discovered, and these noble gases will have to have place in his arrangement, but he didn't explain about those elements they were yet to discover. Okay, so this became the fourth drawback. So I'm writing the fourth drawback here. Newland octave did not have, he didn't he didn't give idea or provisions to like provide proper place, okay, to those element, place for those element they yet to discover. Okay, so there was no position or no idea about those elements they were yet to discover that particular time. There was no place to like place them in his arrangement. So this became the fourth drawback. Everyone are getting the point, no? Do reply, everyone. I'm waiting for your response.
Sir, it's not audible.